Right now, you are moving at over 1,000 miles an hour. You don't feel it. You never have. Your coffee doesn't spill. Your feet stay planted on the floor. And yet, at this exact moment, the ground beneath you is spinning through space faster than a jet fighter. Now imagine that speed just stopped, not slowed down. Stopped. What would happen in the first second? What would happen in the first hour? And why does the answer involve oceans turning into walls of water, the sun standing still in the sky for months at a time, and a magnetic shield that quietly keeps you alive right now without you ever noticing it? Let's start with the moment it happens. Earth spins at roughly 1,000 miles per hour at the equator. Everything on the surface, including you, is moving with it. Your body, the atmosphere, the oceans, the buildings around you, all locked into the same spin. Physics has a rule about this. It's called inertia, and Isaac Newton described it centuries ago. Objects in motion want to stay in motion, so if the planet suddenly braked, the ground would stop, but you wouldn't. Picture standing on a bus that slams the brakes. You keep moving forward even though the bus doesn't. Now scale that up to planetary size. If Earth stopped rotating instantly, everything not bolted down, the atmosphere, the oceans, you, would keep moving at that same 1,000 miles per hour. Buildings would shear off their foundations. The ocean would rise into a wall taller than any mountain range and sweep across continents. This wouldn't be a bad day. This would be an extinction level event within minutes. But here's the parts almost nobody considers. Even the air would turn against you. The atmosphere moving at highway plane speeds relative to the newly still ground would generate winds far beyond any hurricane ever recorded. Meteorologists studying atmospheric dynamics, including researchers at NOAA, have modeled wind shear events far smaller than this, and even those are enough to level forests. This would be thousands of times stronger. So let's ask the more useful question, what if Earth didn't stop suddenly but slowed down gradually, over years or centuries? What would that world actually look like? This is where it gets strange, because a slow stop wouldn't destroy you, it would transform you. The first thing to go would be your day and night cycle as you know it. A full rotation currently takes 24 hours. If Earth stopped completely, one full day would instead take an entire year, the time it takes to orbit the sun. That means if you were standing on the side of Earth facing the sun, you would experience daylight for 6 straight months. Then, slowly, the Terminator line, the shadow separating day from night, would creep toward you over weeks. And when night finally came, it would last another 6 months. Try to imagine that. Not a sunset, a sun descent that takes weeks to complete, dimming so gradually you'd almost forget what darkness looked like. And when night finally arrived, it wouldn't just be dark, it would be cold, in a way modern humans have never experienced. Which brings us to temperature, and this is where things become genuinely apocalyptic. Right now, Earth's rotation evenly distributes heat. Every point on the surface gets a daily dose of sunlight and a nightly period to release that heat back into space. It's a balance. Stop the rotation, and that balance collapses. The sun-facing side would bake for 6 months straight. Researchers modeling tidally locked exoplanets, worlds that always show one face to their star, describe surface temperatures on the sunlit side potentially exceeding 200 degrees Fahrenheit. Meanwhile, the far side, locked in 6 months of darkness, would plunge toward temperatures cold enough to freeze carbon dioxide out of the air, dry ice snow, on Earth. Only a narrow band along what's called the Terminator, the twilight zone between light and dark, would have anything resembling livable temperatures. Life, if it survived at all, would be forced into a thin ring around the planet. Ever wonder why some scientists searching for habitable exoplanets specifically look for this twilight zone pattern? Now you know why. But the sky wouldn't be the only thing that changes. The shape of the planet itself would shift beneath your feet. Here's something most people never learn in school. Earth isn't a perfect sphere. It bulges slightly at the equator because of the outward force created by its spin, a phenomenon physicists call centrifugal effect. Stop the spin and that bulge would slowly relax. The equator would sink, the poles would rise. Geophysicists estimate this reshaping could trigger earthquakes and volcanic activity as tectonic plates adjust to an entirely new planetary shape. The very ground you stand on would be rewriting itself, and the oceans would follow that same reshaping, but on a scale that makes today's coastlines almost unrecognizable. Water currently pools around the equatorial bulge because of the same spin-driven forces. Remove the spin, and that water would migrate toward the poles, drowning entire polar regions while exposing vast new stretches of land near the equator. Coastal cities as you know them, gone. New land, appearing where ocean used to be, the map of the world would need to be redrawn from scratch. Now, you might be thinking, surely something protects us from all this, and you'd be right. But the protection you're thinking of isn't just about temperature or tides. It's about something far more dangerous, something invisible, something that's shielding you from deadly radiation at this exact moment as you listen to this. Earth's rotation doesn't just move continents around, it powers the planet's magnetic field. Deep inside Earth, molten iron churns in what's called the outer core. This movement, combined with the planet's spin, creates something scientists call the geodynamo, first theoretically described by physicist Walter Althusser in the 1940s. This spinning motion generates the magnetic field that wraps around Earth like an invisible force field. Why does that matter? Because that magnetic field deflects solar wind, the constant stream of charged particles blasting out from the sun. Without it, those particles would strip away Earth's atmosphere over time, the same fate scientists believe happened to Mars billions of years ago. NASA's MAVEN mission specifically studied how Mars lost its magnetic field, and with it, most of its air and water. If Earth's rotation stopped, the geodynamo wouldn't necessarily die instantly, but over time, a weakening spin could destabilize the magnetic field that keeps you alive right now, without you ever thinking about it. No rotation, potentially no shield. No shield, and slowly the sky above you starts letting in exactly what it's currently keeping out. So by now, you might expect this to be a story about pure destruction. But there's a twist here that even most science communicators miss. Some scientists point out that a slowly rotating Earth wouldn't necessarily mean zero life. It would mean different life, adapted to entirely different rules. Astrobiologists studying tidally locked planets, worlds already stuck facing their star, argue these worlds could still support life if it evolved specifically for that twilight ring between endless day and endless night. In other words, the question isn't just, would Earth become uninhabitable? It's, would life simply evolve into something you wouldn't recognize? Think about that for a second. The organisms that might survive a stopped Earth wouldn't be humans in bunkers. They'd be entirely new forms of life, shaped by permanent shadow, permanent light, and permanent wind patterns none of us have ever seen. And that reframes everything, doesn't it? Because right now, every single form of life, every plant that photosynthesizes on a daily cycle, every animal that sleeps at night and wakes at dawn, every human circadian rhythm regulating your hormones and your mood, all of it is a direct product of Earth's spin. Your biology is not separate from this rotation. Your biology is a consequence of it. There's a researcher named Colin Pittendray who, in the 1950s, helped establish the entire field of chronobiology, the study of biological rhythms. His work showed that nearly every living organism on Earth carries an internal clock synced to that 24-hour spin. Stop the spin, and you're not just changing the weather. You're rewriting the fundamental rhythm every living cell on this planet has been built around for billions of years. So the next time you watch a sunset, and it takes what feels like 20 minutes to fully fade, remember that 20 minutes only exists because this planet is spinning at exactly the speed it always has. That gentle, familiar fade from light to dark isn't guaranteed. It's a gift written into the physics of a rotating rock hurtling through space. And that everyday moment, the one you barely notice, the sun dipping below the horizon while you go on with your evening like it's nothing. That ordinary moment was never ordinary at all. It was the entire planet, spinning fast enough to keep you alive, quietly doing its job.